I'm Anil Kumar sharing with you questions from previous test paper of rate of change. This will help you to prepare for your own test. We have about 6-7 questions here. We'll begin with analyzing the graph. In the first question, we are given the graph of displacement or position. We need to find where the velocity is positive, 0 or negative. Then we'll analyze the displacement graph and work out where is the acceleration positive, negative or 0. Then we'll have few word problems based on rate of change. The question here is brakes are applied to stop a car traveling at 20 meters per second. The position of the car S in meters at t seconds is given by S of t equals to 20t minus 0.3 t cube. Determine stopping distance, stopping time, and deceleration at 2 seconds. You can always pause the video, copy these questions, try them out, and then look into my suggestions. The other questions here are kind of like this. A car is traveling at 72 kilometers per hour and the brakes are fully applied, producing a constant deceleration of 12 meters per second. The velocity function v of t, where t is measured in seconds, representing its initial velocity and deceleration is, you are given choice of 4 functions. You need to select the correct one. The other question, multiple choice is, a spherical balloon is being inflated. Find the rate of change of volume with respect to the radius when diameter is 20 centimeters. 4 choices are given to you. Then the last question here is the second last question. If a tank holds 1000 liters of water, which takes an hour to drain from the bottom of the tank, then the volume V of water remaining in the tank after t minutes is volume equals to 1000 times 1 minus t over 60 whole square, where t is between 0 to 60. Find the rate at which the water is flowing out of the tank after 10 minutes. The last question here is another application question. A certain electric current I in amperes can be modeled by the function IR equals to 120, where R is the resistance in ohms. Determine the rate of change of current with respect to resistance when the resistance is 18 ohms. So you solve all these questions and then look into my solutions, and I hope that will give you good practice for rate of change. So I have similar videos on related rates, optimization, and sketching, curve sketching. You can look into those videos and prepare for your final exam. Thanks and all the best. Now let us solve these questions one by one and understand the concepts of rate of change. The very first question here is, the graph of displacement function is shown. State whether the velocity is positive, 0 or negative. I've added one portion here, mark region where velocity is increasing. Now the basic concept here is that if the distance or displacement is increasing, that means velocity is positive, correct? So we could say that if displacement is increasing, that implies that velocity is positive, correct? And if distance is constant, not increasing, just constant, not decreasing, that means velocity is 0. And if distance is decreasing, that means that velocity is negative, right? So that is very easy to answer. We could answer all these questions. So when is it positive? So from 0 to A, it is positive, right? So I'm writing positive here. From A to B, distance which is shown on the y-axis is decreasing, right? So here it is negative. From B to C, it is constant, so I'll write 0 here. C to D, it is increasing. Now, if you draw a slope, tangent line, it has a positive slope. We'll look into that also. But increasing means positive, and there the displacement is decreasing, so negative. So that is a very easy way. If distance is increasing, then velocity is positive. Especially when you are given everything positive, this works. The other way which we could do is you could draw tangent lines. So if you draw a tangent line anywhere in this interval, what do you notice? You notice that the slope of this is positive. So slope means velocity, right? So the second criteria which you can look into is slope of tangent line. On S of t, that gives you velocity. Is that okay? So if it is increasing, positive slope. If it is 0, 0 slope. If it is negative, negative slope. Is that correct? Now the main question here, which sometimes you can get, may not get correct I should say, is the part which I have added, which is mark region where velocity is increasing. Now positive does not really means that it is increasing or decreasing. Do you understand? Now if you see this interval between 0 to p, you will find that the slope is increasing. Do you see that slope? It is kind of close to 0 and then it becomes steeper and steeper. So in this portion from 0 to p, we find that velocity is increasing. Do you see that? Now after p, if I draw a tangent line, the curve is below. Do you see that? It is still positive. It is still positive. However, in this portion from P to A, we see that the velocity is positive but decreasing. So now I hope you appreciate that we can actually also figure out from displacement graph whether the velocity is increasing or decreasing. It may be positive, but still, now you see, the slope is higher and moving towards 0. That means velocity is decreasing. So the interval where the velocity is positive and increasing is actually 0 to p. Do you get an idea, right? So this is the region where the velocity is positive and increasing. And it also indicates that acceleration is positive, and that means acceleration is negative, correct? So now we'll take up another graph and understand the acceleration part, which relates to whether the velocity is increasing or decreasing, correct? So this is your next question. And here we are given a graph of displacement with time. State whether the acceleration is positive, 0 or negative. That's what is given. Now how to figure this out? You have to see concavity. So in this particular case, what you really need to do is understand concavity. So if you have a graph which is kind of concave up, in that case we have acceleration which is greater than 0, right? So it is positive. However, if you have a graph where it is like concave down, then the acceleration is less than 0, it is negative, like falling, correct? So now we can answer very easily. 0 to A is concave up. So from 0 to A, acceleration is positive. From A to B, it is concave down, negative, B to C concave up, C to D it is a straight line, correct? So straight line means a constant velocity, zero acceleration. Do you understand? So this means, this straight line means that velocity is constant, maybe positive, that's okay, but acceleration is zero, right? So from C to D it is zero, and there both velocity and acceleration are zero since the object is just standing, it's not moving at all. So I hope that is clear. So to analyze acceleration, or we can sometimes say second derivative, let me write like this, in this case function of time. To analyze the second derivative, you have to look for concavity, not the tangent. To analyze first derivative, you have to look for tangents, right? So I hope this point is well taken care of. And now let's do a word problem based on displacement, velocity, and acceleration. The question here is, brakes are applied to stop a car traveling at 20 meters per second. The position of the car S in meters at t seconds is given by S of t equals to 20t minus 0.3 t cube. Determine stopping distance, stopping time, and deceleration at 2 seconds. So what we are given here is position or displacement, which is S of t equals to 20t minus 0.3 t cube. So if I take the derivative, we get the velocity, which is the first derivative of displacement, which will be 20 minus 3 times 0.3 is 0.9 t square. Second derivative of this will be the acceleration, right? So acceleration is second derivative or derivative of velocity, which is minus 2 times 0.9, which is 1.8 t. So these are the equations with which we can work and answer all the questions. So the first one here is we need to find stopping distance. Now when will this object or the car stop? It will stop when velocity is zero, correct? So at the time when velocity is zero, we can find the displacement. That should give us the answer. Is it okay? So let us see when will the car stop. So that means, stop means what? Stop means that the velocity has to be zero. So that means 20 minus 0.9 t square should be 0. So from here we can find time. So equating that to 0, we get 0.9 t square equals to 20, or t is equals to 20 divided by 0.9 square root. So let's calculate this value. 20 divided by 0.9, and then we'll square root our answer. We get in decimals 4.714. So let's write this as 4.7, right? So we'll just round it to one decimal, please. So after 4.7 seconds, the car will stop. So now we can find stopping distance. So stopping distance will be distance when time is 4.7. So we'll just put 4.7 and then get the answer. So 20 times 4.7 minus 0.3 times 4.7 cube. While using calculator, you could have used 4.714 also, right? Anyway, we'll approximate. So what we have here is 20 times 4.7 minus 0.3 times minus 0.3 times 4.7 cube, which is equal to 62.8. So we'll assume this to be 63, right? So we'll round this to 63 meters. So stopping distance will be 63 meters. Stopping time, we have already found that as equal to 4.7 seconds. And deceleration at 2 seconds we want. That means the third formula, we can substitute 2 for t and then figure it out. So for part C, we know that the acceleration is minus 1.8 t. So when brakes are applied, that means deceleration, right? So after 2 seconds, it will be minus 1.8 times 2, which is minus 3.6 meters per second square. Correct? So that is how we can answer this particular question. Now let's move on and take the next one. The question here is a multiple choice question. It says a car is traveling at 72 kilometers per hour and brakes are fully applied, producing a constant deceleration of 12 meters per second square. The velocity function v of t, where t is measured in seconds, representing its initial velocity and deceleration, is one of these. So which one is the correct answer? Now to get the correct answer, we should convert the units for velocity into meters per second. Then we will be sure. So let's do that. So we have 72 kilometers per hour. Time is in seconds. So we are talking about meters per second. Is it okay? 12 meters per second. So to convert to meters, we know 1 kilometer is 1000 meters, right? And 1 hour is 60 times 60 seconds. So that is how you can easily convert the units. So you can see hours cancel, kilometer cancel, you get meters per second, correct? So what do we get here is, we can cancel some zeros also. So these two, that'll be easy, right? And 6 times 6 is 36, which goes 2 times. Okay, so we get 2 times 10 as 20, so we get 20 meters per second. Okay, so we get 20 meters per second as the initial speed. So 20 is correct for us. And now brakes are applied. That means acceleration is negative. Do you see that? When brakes are applied, acceleration is negative. So minus 12, and therefore part A is the correct option. Some of you can actually differentiate this equation. So we are given velocity as 20 minus 12t. Acceleration will be derivative of this. So that should be minus 12. So that gives you minus 12. That is, deceleration should be negative. So you know A is the correct option. So I hope that helps. The next question here is, a spherical balloon is being inflated. Find the rate of change of volume with respect to the radius when diameter is 20 centimeters. Now we are given diameter, so let's write diameter is 20 centimeters. How about radius? Radius is half of diameter, which is 10 centimeters, correct? Now volume is 4 by 3 pi r cube. Now rate of change of volume with respect to r will be 4 by 3 pi. Derivative of r will be 3r square, correct? Now 3 and 3 cancel. So what we get here is 4 pi r square. Now that is also surface area. Like many of you may know it, that rate of change of volume is actually equals to surface area at that time. Correct? So that gives you the answer. R is 10. So we can now calculate. So it is rate of change of volume when r is 10 will be equal to how much? So let's substitute 10 here. We get 4 times pi times 10 square, which is 400 pi, right? So 400 pi is the correct answer with the units which are correctly written there, right? Rate of change of volume, volume is centimeter cube and radius in centimeters. The next question here is, if a tank holds 1000 liters of water which takes an hour to drain from the bottom of the tank, when the volume is V of water remaining in the tank after t minutes is V equals to 1000 times 1 minus t over 60 whole square, where t is between 0 to 60. Find the rate at which water is flowing out of the tank after 10 minutes. So let's find the derivative of volume. So we are given volume. Let me rewrite this as 1000 times 1 minus t over 60 whole square, right? So rate of change of volume with respect to time will be twice this, that means 2000, times everything inside, t over 60, times derivative of inside function. So don't forget that, which is minus 1 over 60, correct? So that becomes the rate of change of volume. Now if I substitute 10, I get my answer, which is 2000 times 1 minus 10 over 60 times minus 1 over 60. Is it okay? So that is how you're going to calculate. Now you can use calculator to find this answer, or we can do some more calculation here, which is 2000 times 60 minus 10 over 60, okay, times 1 over 60, and let me write down this negative here, correct? So that gives us negative 2000 times, this is 60 minus this is 50 over 3600, right? We can now use the calculator to find the answer, which is approximately, it's of course negative 200 times 5 divided by 36, which is equal to, in decimals, 27.7. So it is rate of change of volume, liters per, time is in minutes per minute, correct? So that is how you can find it out. So basically when you do the derivative, don't forget to write, multiply this with inside function derivative, right? So that is kind of key. So once you substitute t, you can always use calculator and find your answer. That's not a big deal. So 2000 times 50 times 1 over 3600. So we cancel these two zeros, and then we multiplied 1000 divided by 36, which is approximately 27.7 liters per minute. Now here is another question, and this is the last question of our test preparation on rate of change. A certain electric current I in amperes can be modeled by the function IR equals to 120, where R is the resistance in ohms. Determine rate of change of current with respect to the resistance when the resistance is 18 ohms. So we are given a couple of things here. Relation I times R is 120. We are given resistance of 18, and we need to find rate of change of, determine rate of change of current with respect to resistance when resistance is 18 ohms, right? So that's the question for you. So a couple of ways to do it. I'll prefer to rewrite the equation isolating I. It is not a must though. We'll avoid the product rule. So it is 120 over R, and now we can say di over dr is derivative of this is minus 120 over R squared, and now we can substitute R as 18, right? So we get our answer di over dr for r equals to 18 equals to minus 120 over 18, correct? So let's use the calculator. We have 120 divided by 18 equals to, in decimals, 6.66, or we could also write in fractions, no problems. Anyway, so now let me write minus 6.6, and the units will be amperes per ohm. Amperes per ohm. So that becomes the units for the given condition. Right? So I hope this was a good practice for you. So we have learned rate of change with the help of few examples. Feel free to share your comments and views. If you like and subscribe, that'll be great. Also watch my other videos on related topics. Thank you and all the best.